Namaste, Namaste everyone. Welcome to Ray Optics class. We have finished the lens maker's formula, the terrible derivation, coming to one surface, making the rays of light falling on one surface, going to the other surface, the image formed by the first surface acting like an object for the second surface. Hope you have followed it, right? So now we will analyze that formula first. So in what way we have to understand the formula and what is the significance of that formula in many occasions. Now you have lenses made up of two surfaces, and this is the first surface, this is the second surface, and the surface is like this, its center is here, and this is another surface and its center is here, C2, right? And the formula goes like this. So I will color it. This is another surface and its center is C2 here, and the first surface is white one here, so it's here. And it's a thin lens. What do you mean by thin lens? Compared to the radius of both the surfaces, the thickness is very small for the lens. Okay, what is the lens maker's formula? 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. Remember, if you want to apply this formula again to some other problems, again apply the sign conventions. Otherwise, it will not be suitable for that occasion. And another thing is, please put brackets here. Most of the students don't put bracket here. If you don't put the bracket, everything is gone, because it is n2 minus n1 minus into r1 minus r2. This has no connection with this one. You should have a bracket. And I can ask you to remember the formula like this. 1 by f is equal to nl by nm minus 1 into 1 by r1 minus 1 by r2. I can ask you to do it like this way also, where nl, refractive index of the lens, refractive index of the surrounding medium. That is better to understand. Suppose the surrounding medium is r, you will write it as 1. n minus 1 into r1 minus 1 by r1 minus 1 by r2. Okay, so this is the formula. So you can change it like this way also. But this is the standard formula that you have in CBSE book, NCERT book. But this is just for your information, that this is lens, this is the surrounding medium. n2 is lens medium, n1 is the surrounding medium. Now, so if a lens is connected by all these terms like this, this 1 by f is called power of the lens, reciprocal of focal length. We are going to see that in detail later. Now, another thing is, what do you mean by focal length of a lens? There are two lenses in common. There are different types of lenses, but we will study two lenses in common. One is convex and another is concave. If a thin lens is taken, and if parallel rays are incident on a lens, very close to the principal axis, actually these rays should be very, very close to the principal axis, then after refraction they are converging at a point, and this point is called focus. They really converge outside the lens after on the other side, and this length is called focal length. What do you mean by focal length of a concave lens? In a concave lens, if you incident parallel rays of light which are parallel to the principal axis and very close to the principal axis like this, then they will diverge like this. This is a diverging lens in air. So they will diverge in such a way that after diverging, they appear to come from a common point here. So this appears to be common like this. So this should go like this, and this one should be like this, this will go like this. So for a person observing from here, he feels that all these rays are coming from a common point here. This becomes the focus, this is the focal length. Now you will have to go back to the same sign conventions which you have found later. See, every time when I draw the diagram, I prefer the ray coming from left to right in the positive x-axis. That means ray is moving like this here, and focal length is measured on the right side, f is positive. Correct? And here the rays of light are moving in the positive x-axis direction, but from the center. And you have one more point here, that is called optic center of the this lens. For a mirror, concave mirror say, the geometric center is called pole. Out of the whole geometrical size, where is the center? That is called pole. And in a lens, geometric center is called optic center. Geometric center of a lens is called optic center. From the optic center to the focus, that length is called focal length. From the optic center to the focus is called focal length, but you have to measure it opposite to the direction of light, so this is negative. So focal length of a concave lens is negative. Don't by heart it like that. Of course, you should know what is the situation. For what situation it is negative, for what situation it is positive. Whereas in a concave mirror, you see, for a concave mirror, parallel rays met here, so it is negative. Whereas a convex mirror, they diverged in such a way that if parallel rays are incident on the mirror, they diverged in such a way that they appeared to come from somewhat point here. Focal length was positive. So theoretically you have to analyze it. Okay, now for a lens, if you take 1 by f is equal to so much, the formula, if it goes like this. Now suppose if I analyze it like this. If I immerse, I will just take some problems and I will see just small types of problem and analyze it in different ways. If a lens has a focal length of say 2 meter, in general ways I say a simple sentence, a lens has a focal length of 2 meters. When it is kept in air, not so told, that is not told, and nothing is told about the surrounding medium. When nothing is told about the surrounding medium, you take it as air. Suppose it is immersed in a medium of refractive index, say water, say 3 by 2. If it is immersed in a medium of refractive index 3 by 2, what is the new focal length? Right? How to analyze this formula now? A lens has a focal length of 2 meters. Now it is immersed in a medium of refractive index 3 by 2, that is water. What happens to the focal length of the lens? Now, when it was air, you analyze this as 1, correct? And when it is immersed in water, this part doesn't change. Whether it is in water, whether it is in air, the radii of curvatures don't change. When a lens is immersed in water, its radii of curvature doesn't grow like this. It will be the same. So R1 and R2 will remain the same. So what is 1 by R1 minus 1 by R2? It doesn't change. It remains the same. So this part remains the same. What about this part? What happens to this part? Same thing happens here also. Now this part, this which was 1 when it was in air, now rises because it is 3 by 2, 1.5. When this rises from 1 to 1.5, what happens to the answer? Answer decreases. When answer decreases, the difference decreases. Suppose it was 2 minus 1, now it is say something like 1.8 minus 1, answer will be less. So totally this answer will decrease when the surrounding medium refractive index increases, and it will never become negative. Of course, there is a chance of becoming negative, but before becoming negative, we will analyze it. So if a convex lens kept in air has a focal length of 2 meter, once it is immersed in water, this bottom portion or the denominator increases, the total answer decreases, difference decreases, 1 by f decreases, right? If this decreases, of course this is a constant, if this total answer decreases, 1 by f decreases, focal length increases. That is how we have to analyze it. That is the beauty of this formula, and so both will take a role in deciding the focal length of the lens. So in theory exam, if you get a question that will be like this: on what factors focal length of a lens depends? Focal length of a lens depends on refractive index of the lens medium, that means the material of the lens, refractive index of the surrounding medium, and radii of curvatures of the two surfaces of the lens. This is called lens maker's formula because doctor will prefer this one. You will select these two. Of course, there is no chance of selecting other one. Here this should be one because you will wear the spectacles only in air. So this is one. This you will select. Lens maker will choose this one in order to get the same focal length using this medium. So that is why it is called lens maker's formula. Okay, now we will move on to the power of a lens. What do you mean by power of a lens? Power means the ability of the lens to converge or diverge the rays of light. I will take one example. Any medium has the ability to bend the rays, right? And now suppose I take a convex lens of focal length, say 2 meters. What do you mean by that? A convex lens of focal length 2 meters. If you incident parallel rays of light, then the rays of light will meet at a distance of 2 meters from the lens. This is the focus and this is the focal length. This is the optic center. Optic center to focus. All the distances are measured from the optic center now. That is a point in the geometric center of the lens. Okay? Now, suppose I take one more lens. Rays of light are incident on this lens, and this lens is having a focal length of 5 meters, say. The rays of light meet at a distance of 5 meters, and they take a little more distance to get focused. Whereas this lens can focus the rays immediately. This lens can focus the rays very slowly, because they are not bent too much. They are bent a little bit less compared to this one. Compared to this one, they are bent little bit less, so they meet at a larger distance. Now, in terms of bending ability, which lens has more ability to bend? This lens. A lens which has less focal length means it can bend the rays too much and make them to get focused quickly. A lens with more focal length means it is bending the rays little bit and making them to get focused at a larger distance. Its ability of bending is less. That means focal length and bending ability are inversely proportional. Bending ability is power. So power is the reciprocal of focal length. Reciprocal of focal length is called power. It is the ability of the lens to bend or converge or diverge the rays. This lens has more ability to converge. This lens has lesser ability to converge. More the focal length, lesser will be the power. Now, sir, how did you get this formula? Power is equal to reciprocal of focal length. That is a different story. It will be like this. Suppose you take a lens and study its bending ability. How? Apply a parallel beam of light on it. Then if it has too much ability, it will bend it too much. If it has less ability, it will bend it little bit less. Now let us assume that this is the original direction of the parallel beam of light, and it has bent by this much amount. Now you know that this is the focus and this is the optic center, this is focal length. Now this lens was able to bend this light which was traveling like this by this much amount. I call this as delta. And I assume that this ray of light has been incident at a height h from the optic center. From the lens is in the form of a circular object, and from the center and to the height where the ray is hitting the lens, I take it as h. This is h. Now, the ray of light has been bent by an angle delta. Now, can I take this angle as delta? It is also delta, alternate angle, same it is, parallel lines and a bisector, delta. Now, what is tan delta? If you take this, tan delta is opposite side by this adjacent side, focal length. Now, if you analyze this condition and if you try to make this simpler and simpler, that is, this ray of light is very, very close to the principal axis, right? If I take a situation like this, very thin lens and a ray which is very close to the principal axis and it has bent like this, and the angle will be very small, delta. And this angle is also same, and that will also be very small. When delta is very small, what you can write? Tan delta can be written as almost equal to delta. When you know that when theta is very small, tan theta is almost equal to theta, sin theta is almost equal to theta, but cos theta is almost equal to 1. So tan delta is almost equal to delta. So shall I write delta is equal to h by f? Now what is delta is equal to? Suppose h is equal to unity. What do you mean by unity? I will select a distance where this ray is incident, height from the optic center, where it is incident. I'll take this height as unity, either 1 meter, 1 centimeter, 1 millimeter, anything, according to my convenience. If h is unity, what is delta? It is 1 by f. Let us take this as a standard one. All of us, if you want to get the ability of the lens to converge or diverge the rays, let us select a ray of light at a common height from the optic center. Let us make it unity, 1 millimeter say, or 1 centimeter, or 1 meter. If it is made unity, then delta is equal to 1 by f, and that is called power. Power of a lens, this itself is power. This is power. From here we were able to come up to this. Now this is the most simple thing to calculate power. Power of a lens is the tangent of the angle through which a parallel ray of light is bent. right? It is the tangent of the angle through which a ray of light is bent, and that ray of light should be very close to the principal axis. So tangent of the angle through which a parallel ray of light is bent towards its principal axis. So that tangent of the angle through which it is bent, a parallel ray of light is bent, is called power of a lens, and it is a reciprocal of focal length. That's what I have written here. So you can define power in many ways. Ability of a lens to converge the rays or diverge the rays. If it is a concave lens, its ability to diverge. And as it diverges the rays more and more, focus comes closer and closer. Focal length decreases. Suppose this is a lens which can diverge the rays very less like this, then the rays of light come to focus here, or they appear to diverge from here. Suppose you have another lens which has more power, it would have diverged the rays too much and the focus would have been here, very close to the lens. Focal length is less, here focal length is more. This has more power, this has less power. So ability of the lens to converge or diverge the rays of light is called power of the lens, and it is measured as the reciprocal of focal length. Or you can define power of a lens is the tangent of the angle through which a parallel beam of light is bent towards the principal axis, and which is incident at unit distance from the optic center. That also to be defined. So tangent of the angle through which a parallel beam of light is bent at a unit distance from its optic center, that tan delta is called power. Again I repeat, tangent of the angle through which a parallel beam of light is bent at a unit distance from it, from the optic center, is called power, or simply if you want to define, it is the reciprocal of focal length. That's all. Now, so more the power, lesser will be the focal length. It is focused very quickly, very early. Now, sir, what is the SI unit of power? Suppose focal length is in meter, then power will be in diopter. Diopter, D, name of the scientist. Power is in diopter if focal length is in meter. Then, so suppose, but here there is a more chance of going wrong. Sometimes they will say focal length of the lens is 20 centimeter. What is its power? We will write 20 centimeter. We will calculate the power. Of course, that is not wrong, but giving diopter is wrong. Diopter unit will be given for the power only when focal length is in meters. Suppose the focal length of a lens is 20 centimeter. What is its power? Power is equal to 1 by 20 centimeters, 0.2 meters. That is equal to 5. Because you know that 1 by 5 is 0.2. So you can write it as 1 by 5, 0.2. 5 goes to the numerator, 5 diopter. This is the thing related to the power of a lens. Now, so in that case, I was discussing about this 1 by f equal to NL, N2, lens medium, surrounding medium, minus 1, bracket, 1 by R1 minus 1 by R2. Suppose a lens is immersed in water, lens having a focal length of f. If it is immersed in water, what happens to the focal length? Yes, if you analyze it, when it is immersed in water, denominator increases from air to water, that is 1 increases to 1.33. Total answer decreases, difference decreases. If this is decreasing, this is constant. When this is decreasing, 1 by f is decreasing. That means power is decreasing, focal length is increasing. Am I right? Focal length increases, ray of light gets focused at a larger distance inside water, same parallel ray, and power decreases. Focal length increases, power decreases when a lens is immersed in a stronger medium, higher refractive index medium. Okay, now we will go for a small derivation and we will finish it regarding power and focal length. Combination of lenses, okay? Okay. Combination of lenses. Suppose you combine two lenses, what will happen? That's what I am going to derive. Suppose you have a lens like this, its focal length is f1. Say it is some 6 meters. What do you mean by 6 meter focal length lens? The ray of light gets focused at 6 meters. So like this gets focused at 6 meters. Now I will take another lens of focal length 3 meters. What do you mean by that? If I incident parallel rays of light, they get focused at 3 meters like this. So this is 3 meter. Now my question is, If you combine these two lenses like this, f1 and f2, 6 meter and 3 meter focal length. If you incident parallel rays of light to this combination now, these two lenses together, what they will do? Will they focus the ray of light at 9 meters, 6 plus 3? Will they focus the ray of light at 3 meters, 6 minus 3? Will they focus the ray of light at 2 meters, 6 by 3? Or whether the combination focal length is f1 plus f2, f1 minus f2, f1 by f2, or f1 f2 by f1 plus f2. What is the formula? That is what I am need of. So what is this focal length? What is f in terms of f1 and f2? Whether it is f1 plus f2, f1 by f2, f1 into f2, f2 minus f1, don't know. That is what we are going to derive. So we will do it now. Let us take two thin lenses in contact. So combination of thin lenses actually. Thin lenses in contact. We will take two thin lenses in contact. We will take them separately and we will keep them now together. Let us take two thin lenses in contact. That means touching each other. There is no gap between them. If they have the gap, then the formula changes. Okay, this is the principal axis, common principal axis. Okay. The line passing through the centers of curvatures of all the surfaces like this. Okay. Okay, now keep an object here. One ray along the principal axis. Oh, before that I have to give the lens formula. I have not given this one. Let me give the lens formula and then we will start. We have the mirror formula also, right? What is lens formula? Lens formula is 1 by f is equal to 1 by v minus 1 by u. A formula which connects focal length of the lens, object distance and image distance. 1 by f equal to 1 by v minus 1 by u. That is lens formula, and here magnification m is equal to h dash by h, height of the image by height of the object, that is equal to v by u. No negative here. In mirror formula you had negative here, but there was no negative here in mirrors. Here you don't have any negative here, you have negative here. That's the only difference. So this is lens formula. This is lens maker's formula. I rubbed it. Lens maker's formula is different, lens formula is different. This is lens formula, the formula which connects object distance, image distance and focal length of the lens. Very similar to mirror formula, but we don't have derivation of this. Just take this because this is over in your lower classes most probably. You have used this formula. Okay, now we will go to this one. Take two thin lenses in contact and f1 and f2 be the focal length of the two lenses. Take two rays of light. One ray passing along the principal axis, normal incidence because it lies on the centers of all the surfaces and angle of incidence is 0, it passes undeviated. Another ray of light, incident like this. Now, I don't show refraction from surface to surface because it is not needed. This is a thin lens. I show that the first refraction occurs in this lens here and second refraction occurs here and finally the ray moves here. This is the final image and this is object distance and this is image distance. Okay. The two lenses together combined, they produce a combined effect such that the ray of light is bent two times. One is here, another is here and finally like this. So three refractions. One through the first lens, second lens and finally coming out. Now let me remove the second lens. Remove the second lens. What will happen now? If the second lens is removed, first lens alone would have bent the ray like this and would have formed the image like this. Now you have to go for the same idea of lens maker's formula. In the absence of the lens 2, lens 1 alone would have formed the image. Lens 1 alone would have formed the image at I1. So I can't show it by solid lines because lens L2 is present now. In the absence of lens L2, lens L1 would have formed the image here. This ray would have traveled straight like this to meet the principal axis at I1. Now, because of the presence of the second lens here, this had formed the image at I. Now you write the lens formula for each and every lens and don't worry about sign conventions. Simply put the formula as it is because this is a formula applied for each lenses for the lenses we are applying, not for such a situation. So simply apply it and get the answer. Okay, focal length of the first lens is f1 and it is alone forming the image at I1. So for first lens you will write this one. The formula is 1 by f equal to 1 by v minus 1 by u. This is the formula, right? First lens. For the first lens, focal length is f1 is equal to 1 by v, final image. This is a general formula term. What is the image? Where is the image of the first lens? First lens alone will bend the ray only this much. Second lens will do this like this. But first lens alone will do it and it will form the image here. So shall I write this as a v1 distance, image distance? So 1 by v1 image distance for the first lens minus 1 by u. I will simply write the formula as it is. I don't worry about sign conventions because u is here and I will write u. And once you use it, then finally you will apply sign conventions for problems. So this is u for the first lens and v1 for the second lens. I am simply putting the values, that's all. This is the first equation. Now ask the first lens. Lens L1, lens L1. Do you have any object in front of you? Yes, sir. I receive two rays of light and those rays are produced backwards and they come from O. So O is the object for me and U is the object distance. Okay, we have written this. Now ask the lens L2. Lens L2, are you receiving any rays of light? Yes, sir. Is there any object in front of you? I will check it, sir. I receive two rays of light. One ray of light like this, that falls on the second lens. Another ray of light like this, it falls on the second lens. And second lens job is to bend it and form the image here. But second lens now starts checking whether there is object or not. Second lens produces the one ray backwards and another ray backwards. They never meet. When these two rays, one ray coming to the second lens, another ray coming to the second lens, when they are produced backwards, they never met. Second lens says, sir, I was searching for the object by reproducing these two rays backwards. They didn't meet at all. I am confused now. Shall I produce it on the other side? Yes, produce it on the other side. They meet here. That means image formed by the first lens acts like an object for the second lens. Because there is no object on the other side, but two rays are coming from this point. So this acts like an object. So for the second lens, object distance is v1. Do you agree that? For this lens, there is no object distance from this side, but there is an object. This acts like an object. It is v1. What about the image distance? It is v itself, because even though this lens has not obtained any object on this side, it has received a ray of light which is given by the first lens and it is bent and finally the image is formed here at a distance v. Image distance is v and focal length is f2, right? Now let us write the formula. For the second lens, 1 by f2 is equal to 1 by v minus 1 by u. What is 1 by v? Final image is formed by the second lens here only. So it is v minus 1 by u. U for the second lens is v1, which is acting like an object. Actually it is the image formed by the first lens, minus 1 by v1. This is the second one. This is the first formula. Combine them. When you combine them, what happens? 1 by f1. Left hand side I will add 1 and 2. Equation 1 plus equation 2 gives, here it gives 1 by f1 plus 1 by f2 is equal to, left hand side is over, 1 by v1 minus 1 by u plus 1 by v minus 1 by v1. Now 1 by v1 minus cancels. What is 1 by f1 plus 1 by f2 is equal to 1 by v, I will write first, minus 1 by u. Now we will stop at this moment once. We will analyze it now. What is this now? Now, sir, here we have two lenses. The two lenses together form the image, right? There are two lenses here. One lens, second lens. Both are thin lenses and this is the object. And here is the one ray and this ray passes undeviated. This is bent by the first lens, second lens, finally the image is formed here. Instead of, in the absence of second lens, first lens would have formed the image here. Both the lenses together form the image here. This is object and this is image. Now, suppose if I take a single lens, of course this is f1, this is f2, focal length. Can't I get the same situation using a single lens? Sir, I should keep on going searching for a single lens which will do the same job as these two lenses were doing. How it is done? Same object is kept in front of the single lens. It will pass one ray undeviated, another ray is bent such that image is formed at the same place like this. If f is the focal length of this lens, what is the formula for this lens? Formula for this lens is same, 1 by f is equal to 1 by v minus 1 by u, and because u and v are same values, I call this as equivalent lens. What is equivalent lens? Equivalent lens is one single lens which will alone form the image as produced by the two lenses in the combination. So either use these two lenses together or use this lens as a single one. Then what the formula these two lenses together give, same formula will be given by this. So if this formula is the formula for the single lens which is producing the same effect as the combination, why can't you compare this? This is 3, say this is 4. Compare this one. The combined effect of this is producing the same image. Here, single lens alone is forming the same image. So this single lens is replacing the effect of these two. So compare this one. This side and this side are same, right hand sides. Now shall I write it as 1 by f? 1 by f is equal to 1 by f1 plus 1 by f2. So it was not f1 plus f2, it is not f2 minus f1, it is not f1 into f2, f1 by f2, it is this one. Now if there are three lenses, of course, plus plus plus. Now if you write it in terms of power, so reciprocal of the focal length of the equivalent lens is equal to sum of the reciprocals of the focal lengths of each lenses. If you have few more lenses, 1 by f3, 1 by plus 1 by f4 plus 1 by f5, it keeps on growing like this. Now my question is, what has happened to the effective focal length? Now when this lens was having focal length say f1, f2, what is f? Whether it is greater than f1 and f2 or lesser than f1 and f2, that is very interesting now. Now you know that power of a lens is the reciprocal of focal length, right? So finally we got this formula, 1 by f is equal to 1 by f1 plus 1 by f2. Power of a lens is the reciprocal of focal length. What is the power of the first lens? It is the reciprocal of its focal length. What is the power of the second lens? It is the reciprocal of its focal length. What is the power of equivalent lens? It is the reciprocal of its focal length. So shall I write this as power is equal to power 1 plus power 2. What do you mean by this? The total power of the combination has increased. Correct? The power of this is P1, power of this is P2, the total power is added. So total power of the combination of two lenses, when two thin lenses are combined, is P is equal to sum of the powers of the individual lenses. And if you have so many lenses, P3 plus P4, so on. So power increases. What about focal length? It should decrease. How, sir? We will take an example. So if two thin lenses, convex lenses are combined together, focal length decreases and power increases. How? Suppose this lens individually, suppose the focal lengths are 6 meter and 3 meter. Right? Last time I was discussing in the beginning of this derivation. Suppose this lens is having a focal length of 6 meters. It is making the ray to get focused at a larger distance. Okay, f1. Suppose another lens is having a lesser focal length. It is having more ability to focus. It is focusing the rays of light at a shorter distance, 3 meter. Now when you combine them like this, what about the focal length? Substitute the values here. 1 by f is equal to 1 by 6 plus 1 by 3. I can take 6 common. 1s are 3, 2s are 2, 3 by 6. But this is 1 by f. What is f? F is equal to 6 by 3. Is it 2 meters? What do you mean by 2 meters? It is lesser than 6, lesser than 3, lesser than both. Total focal length decreases, but power increases because it is the reciprocal of focal length. So this is a very important derivation. If two thin lenses are combined of different focal lengths, what is the total focal length of the combination? And the focal length combination is given by 1 by f is equal 1 by f1 plus 1 by f2 plus 1 by f3, so on. Total power is P is equal P1 plus P2 plus P3 plus P4 and so on. So power increases, focal length decreases. Of course, that depends on the type of combination also. You can combine a convex lens with a concave lens also. Then you will have to take care of the sign also. This is F1, this is F2, and F2 is negative now, because for a concave lens, if you incident parallel rays, they diverge in such a way that they appear to come from focus. Focus is on this side, negative. Then of course you will get different results. Now, another thing with the power is, suppose you are asked to find out what is the power of a glass slab. Simply I just remembered it, that's why I am just taking that or bringing that into the picture now. Suppose you are asked to find out what is the power of a glass slab. You know that in a glass slab, the sides are parallel, there is only a lateral shift. If a ray of light, of course, if a ray of light is incident like this, and it bends towards the normal, okay, like this, and passes parallel to the original direction. If there is one more beam of light, it moves and becomes parallel. How much it has converged? A parallel beam of light incident on the glass slab has become parallel. That doesn't meet at all. Where is the focus? Shall I write focus is at infinity? What is power? Power is the reciprocal of focal length. It is 1 by infinity, that is 0. No power. What do you mean by a glass slab has no power? It has no ability to converge the rays nor to diverge the rays. It is neither having the ability to converge nor to diverge. That means it makes the parallel beam as parallel only. Its focal length is infinity and its power is 0. Even a plane mirror, when parallel rays are incident on a plane mirror, they become parallel once again. The power is 0, focal length is infinity. It's the beauty of this one. So doctors always prefer power. They don't prefer focal length usually, but you will get it from the reciprocal. So using those values, the lens maker will prepare the lenses. Power will be say like minus 0.5, plus 0.25, plus 0.3, something like that. That is plus and minus indicates whether it is concave or convex. Because focal length, as it is negative and positive, power also becomes positive and negative. So important derivation is over. Lens maker's formula, refraction at curved surface, and thin lenses in contact, everything is important. Now we are left with so many types of problems and we have to combine them. We will see that in the next class, right? And with all the problems of different varieties, and you write all these problems, you have to do one thing. You write all these problems in a sheet of paper, take a sheet of paper, fold it like this, you have A4 size paper, fold it like this, write all the formulas one by one, starting from Snell's law, starting from refraction, refractive index, everything, and put it in a paper. Every time when the class begins, before 5 minutes, look into all the formulas. Then you are recapping all the things in this chapter. That helps you a lot. And then you can catch up everything, because formulas, the first method of preparing for any exam, entrance exam or theory exam, first thing is you should memorize everything. In terms of theory, little bit of by hearting, not completely by hearting. And later you must be able to recall it, because without formulas, no problems. Even with the formulas, it is not over. Once you know the formulas, you must be able to recall it and put it in the exact position and use it in the exact situation. And then you have to analyze it, and that's what you have to do. So finally, I request you to analyze all these derivations so that it will be easier in the next time, because I don't know when the classes will reopen, and once it reopens it will be very difficult. Then there won't be any time, you will have to rush up everything. Suppose you have all these backups, you can do that. So study all these things, get ready for the next class, keep cheering, do well. Thank you for watching.